In the shadows between planets, amidst the vastness of the stars, a unique kind of music resonates. This music isn't made from instruments or voices, nor is it transmitted through air. Instead, it is crafted from electromagnetic waves that flow through the fabric of space. These are the melodies of plasma, a common yet often misinterpreted state of matter throughout the universe. Plasma is not an uncommon or unusual substance. It is found everywhere. From the intense cores of stars to the shimmering auroras seen at Earth's poles, plasma is ubiquitous. It exists within solar winds, in the magnetospheres of planets, and in the ionized gases of distant nebulas. Unlike solids, liquids, or gases, plasma comprises charged particles, electrons and ions, that move freely, interact, and respond to electromagnetic fields. This distinctive characteristic gives plasma its voice, allowing it to communicate through waves. As particles within plasma accelerate, they generate waves, oscillations of electric and magnetic fields. When spacecraft traverse these waves, they register the variations. Utilizing the right equipment, we can transform those patterns into sound. This is not a scene from science fiction. NASA's Voyager, Cassini, Juno, and Parker Solar Probe have recorded these waves. They are tangible, measurable, and tangible. What we hear is astonishing. High-pitched chirps resemble the songs of birds at dawn, while descending whistles mimic falling droplets. There are rhythmic background hums and occasionally unsettling tones that rise and fall like a long-lost melody. These plasma sounds are not just aesthetically pleasing, they are meaningful. They provide insights about the surrounding space, where each frequency conveys information about density. Every modulation reveals details about magnetic pressure, and each burst signifies an occurrence, a solar flare, a shock wave, or a collision. Scientists classify these waves into categories. They include chorus waves, whistlers, electron-cyclotron harmonics, ion acoustic waves, hiss, and others. Each has a unique signature and contributes to the cosmic orchestra. Perhaps the best known are the chorus waves. They frequently emerge after geomagnetic storms and fluctuate in tone like a choir of birds welcoming a new day. These waves, unlike birds, originate from electrons spiraling along Earth's magnetic field lines. When solar particles collide with our magnetosphere, they energize electrons. These electrons interact with plasma, generating the chorus. Remarkably, these waves do more than just produce sound. They have an impact. Chorus waves can propel electrons, modify the Van Allen radiation belts, and alter the architecture of near-Earth space. Plasma waves affect auroras, influence space weather, and can either prevent or cause satellite malfunctions. In extreme cases, they may even disrupt power grids on Earth. There is more to discover. Whistler waves, for instance, were uncovered during World War II. Radio operators recorded unusual descending tones during lightning storms. Scientists later connected these sounds to lightning striking plasma in the ionosphere. The resulting wave traveled along Earth's magnetic field while decreasing in pitch. Then there's hiss, a broad emission resembling gentle static. It fills the inner magnetosphere and may connect to lightning and other planetary phenomena. Every planet exhibits its own unique wave profile. Jupiter's massive magnetosphere resonates with intricate overlapping tones. On the other hand, Saturn's plasma waves are more structured and resonant. Uranus and Neptune create deeper, more enigmatic sounds. Even moons contribute to this symphony. Io, one of Jupiter's moons, releases sulfur and other materials into Jupiter's magnetosphere. This engenders unique plasma interactions that impact the entire Jovian system. And what about the Sun? The Sun is a colossal sphere of plasma that churns with magnetic storms. Its corona, the outer atmosphere, is hotter than its core, a mystery yet to be fully explained. Some scientists propose that plasma waves might provide insight into this phenomenon. These waves could transport energy from the Sun's surface into the corona, helping to clarify the extreme temperatures we observe. If this holds true, it implies that voiceless music is fueling the Sun. This concept, vibration transmitting heat across space, echoes ancient beliefs. Philosophers once spoke of the music of the spheres, suggesting that the motions of planets and stars generate harmony. Today, we understand they do, though not audible as before, yet we possess the means to hear. With our tools, sensors, algorithms, and imagination, we explore sound. So, what shall we do with this knowledge? Should we merely listen, analyze, and share these sounds with the world? Many scientists argue that the public should have access to the music of space. It's not solely a scientific endeavor, it is fundamentally human. We have a desire to appreciate beauty. We need to remember our place within a grander system. The universe is not devoid of sound. The cosmos communicates, not in words but through frequencies. What we hear is profound, reminding us that life embodies rhythm and matter signifies motion. Energy encompasses not just force but expression. If you've gazed into the night sky and sensed something invisible and unspoken, perhaps that is why. Perhaps your body was attuned to the universe. After all, the calcium within your bones was born from the heart of a star. The oxygen you breathe once flowed through plasma. Your heartbeat, your breath, your brain waves, they all resemble waves. They all contain music. So tonight, as you find calm in the darkness, keep this in mind. You are not enveloped in silence, you are surrounded by song. The universe surrounds you with unseen melodies. Through listening, you forge a connection to everything. Let's explore further. Instruments aboard spacecraft such as Themis, Van Allen probes, and Cluster are detailing these plasma waves with precision. Their data enable scientists to model space environments in real time, predicting the when and where of plasma interactions. The accuracy of these measurements has advanced significantly. Scientists can reconstruct the environment around a spacecraft with astonishing detail, mapping energy movements, particle accelerations, and frequency shifts. In Earth's upper ionosphere, low-frequency waves are influenced by both solar wind and terrestrial phenomena, storms, lightning, and even earthquakes. Research is growing around the relationship between seismic activity and electromagnetic disturbances in the ionosphere. Could the tensions of Earth resonate upward into the sky? Might these echoes blend with solar plasma, forming waves we have scarcely begun to identify? As we venture beyond the solar system, interstellar plasma flows between stars, cold and rarefied yet not silent. The Voyager spacecraft, now in interstellar space, have detected plasma vibrations there as well, indications of density, shocks, and waves where no stars illuminate. Plasma physics is integral to fusion research too. Here on Earth, scientists strive to replicate the conditions of the Sun. Tokamaks, stellarators, and laser confinement systems employ intense magnetic fields to contain plasma. In these reactors, plasma waves play a crucial role. They inform researchers about the stability of reactions, energy losses, and fusion occurrences. Understanding plasma music enriches our ability to listen to space and guides us in constructing stars. Some thinkers extend this notion even further. They theorize that vibration, oscillation, is not merely a consequence of matter, but its essence. String theory, for instance, suggests that particles are vibrating strings. What we identify as mass or charge may represent the musical note a string produces. Could it be that the universe is genuinely a symphony, not just symbolically, but in its core composition? Are atoms themselves songs? Are you, the listener now, a melody woven from stardust? If so, then every plasma wave we capture transcends science. It embodies communion. It signifies a shared moment between a resonating being and an ever-singing cosmos. Allow that thought to resonate tonight. Everything vibrates, every silence hums. When you immerse yourself in the universe, you are not alone. You are a listener, a voice, a part of the grand cosmic harmony. Next time on The Cosmic Whisper, galactic fossils, the stars that remember the beginning.